Hello, St. Paul guys, and we're ready to get started a little bit of math. So hopefully you enjoy, and hopefully this will work well for the class. Let's get started on a little math. All right, so here's our first problem. We have a system of three equations. So let's call equation 1, 2, 3. We'll just number 1, 2, 3. And what I want to do is I want to try to get these, instead of having three equations, three unknowns, I want to somehow rearrange to where it's two equations, two unknowns. So I'm going to take equation number 3 and get it in terms of x. So if I want to just get just x equals, so I'm going to do x and then move everything else, so move the y and the z over. So I'm going to then do x and then it's equal to negative 5y, and then it'd be a positive z, and plus negative 20. So that'd be our new equation in terms of x. So what I want to do, let's call that equation 4. So what I want to do now is I'm going to substitute in for equation 4. I'm going to put that into equation 1, and I'm going to take equation 4 and put that into equation 2. All right, so if I take equation 1 here, it says negative x. Well, we're putting in place of x. What are we putting in place of x? We're wanting to put, so a negative of our negative 5y plus z minus 20. And then the rest of that particular equation 1 says minus 5y minus 5z equals 2. All right, we're going to do the same exact thing for equation 4 into equation 2 there. So I'm going to take my 4 times whatever the value of x was, we said was minus 5y, plus z minus 20, and then put in the rest of our problem. It's minus 5y plus 4z and equals 19. All right, so we have all of that problem. So let's go ahead and clean this up a little bit and see what it looks like. So we have a negative in front, so I have here I got a positive 5y, a negative z, and a positive 20. And then still the rest of it just kind of drops down, minus 5y minus 5z equals 2. So now I can start kind of combining like terms. So I know I see a positive 5y, negative 5y, so those are going to cancel. I have a negative z and negative 5z, so it's going to give me a negative 6z. And I want to move that 20 over, so minus 20, so it's going to equal negative 18, right? So it's going to equal negative 18. All right, next problem. So over here, let's clean that up a little bit. So 4 times 5, we have a negative 20y. Cleaning this up, so 4 times z gives me the positive 4z. 4 times a negative 20 gives me negative 80. And everything else just kind of stays right there where it was. All right, so let's see what we got left here. So I have a negative 20y and a negative 5y. So we know we can put those together and give me negative 25y. I know I have a 4z and a 4z, so I can put those together and give me 8z. And I have this negative 80 that I want to move over to the other side. So if I move that over to the other side, by adding the 80, it was going to give me 61. All right, this one already, so let's call this now equation 5. So I can already solve for what is z. So I don't have to do anything extra except for just solve for c. Here you can see that we already know that z is going to be equal to 3. So I can plug that in this value and find out what is y. So I can do my negative 25y plus 8 times 3 is equal to 61. So now I know I got negative 25y plus 24 equals 61. Move it over. And negative 25y. So negative 25y equals, move that over, so 61 minus 24. Oops, here I see I already made a mistake. That should have been 99. So that should have been 99. So here I have 99. So here I have, once I subtract that, I get 75. So I'm going to divide by negative 25, and y is equal to negative 3. So now I can plug all those values in, and it doesn't matter which one you pick, any one of them that has an x, y, and z, and solve for x. So I'm just going to pick equation 3. It's already solved in terms of x. So I can put in negative 5 times negative 3 plus z was 3 minus 20 and see what x is equal to. So that gives me 15 plus 3 minus 20. So it gives me negative 2. Alright, so we know x is 2, y is negative 3, and z is 3. Alright, at this point, if you kind of get how to do it, I want you guys to pause the video. So pause it at this point and see if you can work it out and get what the answers are at the end. So you got the problem, you got it right, you did it well, keep going, you'll get there eventually. Alright, this one, because it's already like I see is z, there's no coefficient there on z. So just to make my life easier, make it a little bit less step, I'm going to go ahead and solve this equation 1 in terms of z. And I don't like dealing with negatives over here, so what I'm going to do is just flip-flop z and 18. So if I have negative 4x, I have a minus 5y, and we're going to end up with minus 18 is going to equal to z. Alright, so what I'm going to do now is take the new equation 4 that we made in terms of z, and I'm going to put that into equation 2 and into equation 3. So once again, I'm going to take my standard equation 2. It says negative 2x minus 5y minus 2 times our new z, and our z says minus 4x minus 5y minus 18, and then it says equals 12. Alright, over here, equation 4 into 3. So I'm going to take, once again, same thing, negative 2x plus 5y plus 2, and then put in what is z. Well, z, it says, is negative 4x minus 5y minus 18. And then the rest of our problem equals 4. Alright, after simply distributing here, so we can see I'm now distributing, so let's go ahead and look and see what can I clean up, and let's get some like terms put together here. So I have a negative 2x, a positive 8x, so I can put those together. Let's make that 6x. I have a negative 5y and a positive 10y, so it's going to give me a positive 5y. And let's go ahead and move our number over. So I'm going to subtract 36 and give me equal to negative 24. Alright, so let's go ahead and do the exact same thing over here on this side. So let's clean it up a little bit and put our like terms. So I have a negative 2x and negative 8x, so that's going to give me a negative 10x. We have a positive 5y and negative 10y, so it's going to give me a negative 5y. And then I can move my number over, so let's move our negative 36 over, and that will give me then 40.
Daddy, I have this.
Alright, so now you can see this problem is exactly like what we were just doing in class. So I can simply add these two equations together. So what happens if you add them together? Because that way we want to cancel out one of the variables. So negative 6 and a negative 10 gives me a negative 4x. And that is therefore equal to 16. And so if I divide it out, I can see x is going to be negative 4. So I've already solved for one of them. So let's go ahead and pick. I don't care which one you want to do. Whichever one makes it easier on your life to plug in x into and solve for one of the variables. So I'm going to pick whichever one has the smaller of the numbers. So I'm going to go over this way.
So you got the problem, you got it right, you did it well, keep going, you'll get there eventually.
And
awesome.
we get everything substituted into that equation that we were talking about and looking at. So we get negative 24 plus 5y equals negative 24. And so once I move that over, you can see that's going to cancel out. So I'll get 5y equals 0. Therefore, y is equal to 0. So now I have x and I have y. All right, so just pick one of the original equations to substitute in. I usually try to find whichever one has the smallest overall numbers, just because I don't like anything big for numbers because it makes my life easier. So I know I have a negative 2, and we're going to put in our value of x. All right, so our was negative 4 was our value of x, and then plus 5, we know 5 was 0, so I got plus 2z equals 4, and I can, so this is going to be a positive 8 plus 2z equals 4. Once I just move that over, so I get 2z equals negative 4, and z equals negative 2. So we know x is negative 4, y is 0, and z is negative 2. And there is our answer, and we're done.